Next, we're going to talk about bone structures and features. So, this is a long bone. A long bone is what you typically think of as a bone. You think of your femur, you think of your humerus, your radius ulna, tib fib. They have a epiphysis at each end. These epiphyses are going to join at a joint with another bone. Then we're going to have an epiphyseal plate, otherwise known as a growth plate. This is where the growth in the bone happened, the elongation. This is going to then go into a metaphysis. This is transition zone before coming into the diaphysis, which is the shaft of the bone. Now, the metaphysis is not mentioned in this image, but it would be this transition zone right here. Then the shaft of the long bone. Inside the long, or not inside, but when we look at the actual tissues of the long bone, we'll be looking at things like the outer cortex region, which is going to be composed of compact bone, followed by the inner medullary cavity, which is going to have both spongy bone and be where the bone marrow is going to be located, either red or yellow. And we're going to have some membranes involved here as well. So there's a lot of different things to go over. Here's another long bone. All right, so the shaft or diaphysis of the long bone is cylindrical in shape. It's going to be composed of compact bone, and that compact bone is going to surround a marrow cavity, otherwise known as the medullary cavity, and lined with endosteum. Endosteum is a layer of osteogenic cells and reticular connective tissue. Osteogenic, osteobone, genic, producing or originating from. So these are bone-producing cells. We will talk about the nature of compact bone here in a couple of audios. So the diaphysis, what is its purpose? Well, think about where we find these bones. Think about your femur, think about your tib fib. The diaphysis is going to bear most of the weight of the bone itself, and that endosteum is actually going to keep the bone marrow separate from the compact bone. And this is important because of what the bone marrow may contain. It will either be yellow or red, and those are going to have two different substances. The enlarged ends, or the epiphyses, are going to be spongy bone covered in a layer of that compact bone. We will talk about what makes spongy bone spongy. Its shape, its impact, why it is what it is, in a couple of audios when we talk about compact bone. What is its purpose? It's enlarged to strengthen a joint, and the epiphysis is where many tendons and ligaments attach, so being enlarged for those attachments is beneficial. The end of the epiphysis, where it joins with another bone forming a joint, is going to be covered with articular cartilage as well as lubrication. This is going to allow for gliding. The remainder of the bone is going to actually be covered in a membrane called periosteum. It's an outer fibrous connective tissue layer composed of collagen fibers. This periosteum is going to run continuous with tendons, or it will have perforating Sharpie's fibers that penetrate into the bone matrix. We'll talk about those in a second. It is the periosteum that is what's going to connect the bone to the tendon. The inner layer of this is going to have an osteogenic layer, and that's going to become important for growth and healing. Now, the epiphyseal plate or line is the growth plate. Its exact distinction will depend on your age. If you have not finished your growth spurt yet, that epiphyseal plate or line is actually going to look like a bunch of cartilage, because it is. Your epiphyseal plate is actually composed of cartilage, and it is a race between the generation of cartilage and the filling in of that plate with bone. That is what is triggered during a growth spurt. So once the bone has caught up to the cartilage, you are done growing in that particular bone. It is now completely fused. We can actually tell if you are done growing or not if we take an x-ray of your pelvis. It's not a long bone, but there is a growth plate for all of your bones, regardless of whether or not they're long bones or not. And the growth plate for the ilium, or iliac crest specifically, so if you stick your hands on your hips, those two bones right there, that is the ilium or iliac crest. It's a distinct feature of the ilium. The ilium is the name of the bone there. That growth plate is the last to fuse. So if I take a x-ray of your pelvis and I can see that the growth plate has not completely filled in, hasn't completely fused, I know you're not done growing. If it's only 25% of the way, you still have a long way to go. If it's almost to the end, that means you're almost done. You're not going to grow much more. So we can use that as a guideline. All right, speaking of marrow, yellow marrow is fat. All of your bones, when you are born, start off as red bone marrow. Red bone marrow makes red blood cells. So when you are born, you are churning out red and white blood cells like crazy. However, as you age, that red marrow, it is replaced with yellow marrow. And yellow marrow is just fat. So as you age, your red blood cell production is replaced by fat storage. And this continues as you get older and older and older. There's a reason why our older patients have, as a population, lower red blood cell counts. We use a different table for them because they're not making as much blood. Compact bone is a strong but very heavy bone, which we'll talk about the actual structure and histology of in two audios. Spongy bone is a lot less dense and therefore a lot less lighter. But again, a couple of audios will talk about that in detail. There will be nutrient foramen. Foramen is a fancy way of saying a hole that allows blood vessels to enter and exit the long bone in question, allowing for the bone to get nutrients and oxygen and get rid of carbon dioxide and waste products. Here's another explanation of a long bone. Here's that periosteum again, just a repetition. Some more repetition. We'll get into the trabeculae of spongy bone when we get into our histology audio. Now, we've been picking on long bones, but bones come in a variety of different classifications. We also have short, irregular, flat, and what's not mentioned here is sesamoid bones. Short bones. Short bones are, well, actually, let me back up. Long bones are typically bones that are more rectangular in length. So think of the bones of your fingers and toes, forearm, upper arm, shin, thigh. Rectangular shaped bones. Short bones are more square shaped bones. So those are going to be more along like the bones that form up your wrist, the 8 carpal bones. Irregular bones are ones that don't easily classify into anything. So these are going to be things like your vertebrae or your heel bone, your calcaneal bone. A lot of your facial bones fall under irregular. Flat bones are, well, like they sound. These are going to be things more like your scapula, your pelvic bones, the plates of your skull. They're far more flat in nature. Ribs actually are classified as flat, by the way. And then not pisiform. The sesamoid bones are sesame-shaped. They look like sesame seeds. Now, the most frequently talked about and famous sesamoid bone is your kneecap, the patella bone. Sesamoid bones are found embedded at joints in the tendons, and as far as we are aware, they are critical to stabilizing the tendon around a joint. We only count in our bone count the patellar bone. there, but a lot of the joints in your fingers and your toes, they have sesamoid bones as well. When you have that, you have 200 some odd bones in your body. Those aren't counted because they're super, super tiny. Some people have them, some people don't. Some people have more, some people have less. And a lot of times they're really hard to pick up on x-ray. They're actually relatively new, and by new I mean in the past 30, 40 years, development in our understanding of our anatomy. So we really only talk about the patella because it's the one we can actually see and we've known about the longest, and everybody has one, for the most part. Some people's patellas, though, are cartilage, not bone, and that's due to a genetic miscode. The bone just never ossifies. That can happen in a variety of different places, actually. All right, so anyhow. So when it comes to the structure of short, irregular, and flat and sesamoid bones, they are going to be thin plates of periosteum-covered compact bone on the outside and endosteum-covered spongy bone inside. We're not going to have diaphyses, we're not going to have metaphyses, epiphyses, because they're not cylindrical. They will still have growth plates, however. They will still have bone marrow, but that bone marrow is going to be found between the trabeculae of the spongy bone. There is no marrow cavity. In flat bones specifically, the internal spongy bone layer is known as a diploe, and it basically looks like a very stiff sandwich, which is what is shown here.